distance around is, if I add up all the sides, what's the distance around?
42.
So 42 meters around. So that's the perimeter. If I were to add the long side, the short side, the long side, the short side, walk around the thing in a circle, that's what it would add up to, right? Good to know. Then it says some other stuff. The length of the path is 3 less than twice the width. Give me a second to think of the easiest way. Because it's true, I know like Taylor brought up last time, it's possible to use 2 letters. But I'm going to try to choose one as far as just like a W or an L. So you guys help me. How did you set it up? For what? Okay, so you said, I guess then that means that you said let X be the width?
Yeah.
So you said let X equal width. And you probably said that because the relationship you have, and I'm going to write this in words so everybody can see it with me, is that length is equal to, and I almost gave you like a straight formula from there. Length is equal to 3 less than twice the width. So using X for the width makes a lot of sense since the words over on this side, that's where the width was at, right? So if we use the X for width, we can just substitute it. So we had, you said 2X, right, Taylor? And then minus 3? It doesn't matter which one you define. It doesn't matter if you would have said let X be the length or X be the width. The point is that once you have decided your X, when you get into the statement, this came straight from that sentence I read to you in the book, this length equals 2X minus 3. Once you get there, the important thing is that you're consistent with that first definition. And she was really smart to use the width as the X, because when you looked at the words, that's the word that was kind of nested in there with all the description stuff. So that made it easier to choose width as being the letter we don't know. The other way, I mean, you could have done it, but it would have been harder, kind of. It's good to use the nested words as the letter. Okay, so we have this. Now let's put it on the picture, though, because that'll probably make it even easier. So on the picture, I'm going to put 2X minus 3, and over here I'll put an X. And actually, if we're talking about the distance around, we're talking about the length of every single side, right? So this one on the right, what's its length? Okay, on the bottom, you got it. So to me, the picture is really substantial, because from that, what I can say is, oh, okay, well, if I walk around this thing, maybe I should actually come down here. If I walk around this thing, you guys help me. What do I have? 2X minus 3, right? Plus what?
2X.
Well, I'm going to walk around. I'm going to start here at the top and just kind of walk. I know it doesn't matter, but I'm going to actually go around in order and just add up every single piece. Because I know that if I add up every one of these lengths, I'll get to 42. So you can do formulas and stuff, whatever. I'm just trying to make it so anybody could kind of think through it without a formula, you know. So you have 2X plus minus 3, the top one. Then I'm going to say, okay, I'm walking around, so plus the length of the X. Keep walking to the bottom, so plus 2X minus 3, plus the other X. And when I walked around and added all those pieces up, what were they equal to?
42.
You got it. And it's true, if you know some kind of times the 1 by 2 and the other times 2, who cares? I don't care how you add up those sides if you do some kind of little thought process. The point is that it's going to end up being the same thing that we have down here. Like terms, let's put them together. We have lots of X stuff. A 2 plus a 1 plus a 2 plus a 1. What kind of X's do we get? How many? The 6 of the X's. And then the regular number, what do we have left? Negative 6. Okay, is equal to 42. So we want to get X by itself, so remember we start with what's least attached. So that'll be the minus 6. How's the minus 6 attached? Subtraction. Opposite of subtract is? Okay, so we'll say add 6 to cancel it. You do it to one side, you have to also do it to the other side. I'm going to bring down the 6X that I've got left equals 42 plus 6, 48. We want X alone, so let's get rid of the 6. The 6 is attached to my multiply, so the opposite of multiply is divide. So we'll divide by 6. What you do to one side, you also do to the other. So X is equal to 8. And you can test it. Go plug it back in to see. And remember, it wanted, are we done? Well, what did it ask me to find? Length and the width. What is this one? Okay. So it's important at the end of the problem to say, hey, did I actually finish this thing? No, we got most of it, though, the width. And once I have the width, can I get the length? Sure, we defined it right there. 2x minus 3. So 2 times 8 minus 3. What's the length? What were the units in this problem? Meters? Okay. And actually, really, you should always check that before you start it to make sure they all match. But we just made that assumption. I should have been a little more careful, probably. How are we doing so far? Are people okay? Let's see if it's not going to look at me because that's mean. Kel, are you holding on? Are you okay? With this one? That's what happens with a lot of these. And I used to have trouble with word problems also, because a lot of times it's kind of like all these words, what the heck am I supposed to do? But then if you can start making, like writing down the words in them and drawing the picture, it becomes easier all of a sudden. But it's different from one to the other, so that's why I used to get frustrated when I was in school. Now you can do it again. And what you did, Taylor, with the recommendation of the width, that was so key to this problem. Because even when I first looked at it, I was thinking this is going to be hard without cheating and using 2 letters. Which you guys will learn to use 2 letters later. But when you're making just like, you know, you only want to have X's in the problem because you can't use an X and a Y, it's harder sometimes. Carpentry, we have a 12-foot board. And it says it's being cut into 2 pieces. Okay, so let's make our board. Cutting it into 2 pieces, we'll just draw a line somewhere. What's the length of this board? 12 feet. 12 feet. Okay, so that's good. I'm drawing a picture, even though it was horrible. Okay, and we know some things. Twice the length of the shorter piece is 3 feet less than the length of the longer piece. Well, that's nice. I mean, I guess so far we know that one piece is shorter than the other, but that's a lot of words, isn't it? On our picture, can we use the 12 feet to label anything about the relationship before we get started? So you know that this is going to be something you're looking for, whichever one you want to put it on. But the other piece is going to have to be the total length, 12, minus whatever that small piece was. Do you guys remember seeing that pattern before? Where we say, you know, if I knew the length, for example, let's say I knew it was 2, well, I would say 12 minus 2 gives me the other piece. If I knew it was 3, I'd say 12 minus 3 gives me the longer piece. So we're using the idea that the 2 of these add up to equal the long one, to equal the 12. And the opposite of adding them to get 12 would be to subtract one of them from 12. That's the opposite way to do it. That's why instead of a number, we can say 12 minus x. You guys okay? Now that we know this, it's going to make these other words, this kind of whatever that we have to deal with here, a lot easier. Because it says twice the length of the shorter piece. I'm going to use my picture. It doesn't matter which one you drew is bigger or smaller. It only matters that you are consistent. On my picture, I made the x shorter. Who cares which one was short? I mean, that x could have been like a 10. But I'm going to go off my picture to be consistent because that's the only important thing is that consistency from my definition. Remember our last class when Kelly did the problem on the board that was different from us because she defined her stuff backwards from what we did? And it was okay because after the way she defined it, she used the problem consistently with how she made stuff multiply to the stuff she set up. Okay, so on this one, twice the length of the shorter piece. What's that sound like? 2 times what? According to the way I've set it up. Okay. 2 times x, or 2x. Okay. Then we have is. Okay, we'll put equals. Less than, is 3 feet less than the length of the longer piece. Less than. That means a minus, but where does the minus go? At the end, or at least after whatever it is it's talking about right then. So minus 3 at the end. The length of the longer piece. That's what comes in front of the minus 3, right? What's the length of the longer piece? Sometimes you may have to use parentheses. In fact, fact, a lot of times, there was a problem Rob asked me about a second ago, where if you didn't use the parentheses, it actually messed up the problem. But in this one, does it mess it up if I didn't write the parentheses? Or can I just drop them? We can drop them. Okay. So it's always safer to go ahead and write them. That way you can drop them later. So we have 2x is equal to 12 minus x minus 3. Let's simplify. 12 minus 3, what do I get? So 9 minus x equals 2x. We have x's on opposite sides, so let's move one over. I'm going to take this one and move it over. That's what I'm going to choose. So when it comes over, the sign changes in front of it and it becomes positive, right? Like that. So we actually have x positive 2x equals 9. 1 plus 2. So I have 3x equals 9. To get my x by itself, I want to get rid of that 3. 3 is attached by times. The opposite of times is divide. So we'll divide by 3. And x is equal to what? So back on the picture, we have that this right here is 3. And then 12 minus 3 is equal to what? 9. Those are our two lengths. And let's see, 9 plus 3 is equal to 12. We probably didn't make a huge mistake. Since at least, you know, some of the basic stuff does set, we can see that it works. You really should, yeah. We should put feet. On the test, I probably wouldn't count off for no units, but it's a good practice because it shows you know what's going on.